Cool. Okay. So, how's it going? Hi, everybody. Sorry for not remembering to record our last stream. I really was happy with that stream too, so I was bummed out that we didn't record it.
Yeah, me too. But I'm learning, so
Yeah, no,
hopefully.
I didn't mean that as like
Yeah,
you
I
should have
know,
recorded
I know,
it.
but I wanted to tell them that it was like, because I'm the one usually
Recording.
broadcasting. Yeah,
Yeah.
because I have the two monitors, more space than Eliza.
I have one.
But I haven't used OBS before, like in my life, like just now when I'm doing this thing with Eliza, so I'm getting used to it.
Yeah. Well, once we get the hang of it, it's like once we figure out the little recipe for it, it's not so bad.
Yeah.
So today we're recording, so we'll have a replay for people who aren't here now, who
Yeah.
probably don't care because they're not here right now. But yeah. Okay.
Wow, 10 people now. Hello, everybody.
People?
I mean, nobody is chatting, not all of them, but I can see that there's 10 people.
Really?
Thank you for being here.
135? Hi. Cool.
Ah, wait, Macu135 is Lionel. Aren't you?
Are you the one who does
France?
the crazy shader stuff
Yeah,
in observables? Because I was reading that article and I want to put my any day shaders in observables as well as like a little notebook. So if that's you,
I
you're
think
super
it's him.
inspiring.
Yeah, it's him.
Yeah,
Okay,
it's him.
cool. Yeah, your shaders, dude, are like,
So
ooh,
good.
when you join the Any Day shaders, blows my mind is the usage of these keyframes. It's really lovely, your work.
Yeah. Thanks for watching. Now it
Yeah.
feels like really a little bit of pressure.
Yeah,
Cool.
I know. Which, by the way, I wanted to say something for the ones that are like tuning in, that the kind of shaders that Eliza and I get to build, if there's like very pro people right now, shaders watching us, do not expect us like coming up with things like shader toy, because we are getting started.
Where we do like 3D fractals, yeah.
Exactly. So this is the reason why Eliza and I are doing this, because we want to just improve, but we're still like beginner level, so don't expect something like that advanced. Just I wanted to put it on a note, because I imagine maybe there could be some people that are really, really good at shaders watching that and then expecting us to like maybe come up with very complex things, which we don't want to. And we also want to help other people, maybe curious into shaders, to get started. That's why we go like, we try to make maybe complexity out of complex code. That would be like so far. Or
make complex things with simple code.
Yeah.
Yeah. Yeah.
For now.
I'll take a complex visual, but I want simple code. And that's as much in shaders as it is in web dev or anything. I have a lot of respect for people who can dive into extreme complexity, but that's not my thing. I just want it to be simple and clean and understandable and make something pretty happen on the screen.
Yeah, same. So I just wanted to put it out there in case like somebody's watching, and yeah, who knows? Maybe it will change in the future, but for now it is.
Yeah, I mean, one of my ex-boyfriends from a long time ago, who was learning, he was in design school. I remember him telling me something that his teacher had said, which was that like, it's super easy to do. I mean, I don't know how true this is, because I think if you can do complex like math, then it's probably not easy. But the teacher basically was telling him that it was very easy to take a complex approach to problem solving or to find a solution for what you're trying to do. And it's actually quite difficult to whittle it down to like something simple that's easy for other people to understand and still something visually that you enjoy. So I was like, okay, I like that philosophy. And I also just like when things are simple. So that's been my approach. So yeah.
Yeah. And I guess I just wanted to add to that maybe again, because it could be like new people is watching, that maybe part of the reason that why Eliza have this mindset too is because even when we are like developers and we program nowadays, we didn't study any engineer or development career. We were completely self-taught, and we also like a lot of like design and media and other fields that I don't know if I imagine that that's part of like why we feel this approach into like the code of shaders.
Yeah, self-taught, definitely did not study computer science in school. I remember being like, why would you want to do that in high school? Now, with everything that I know, I kind of wish that I had, but
Me
at the
too.
same time, yeah.
It's very
They
curious.
didn't really frame it in a way that was very inviting, enticing.
Exactly. I didn't think it
And
would be fun.
yeah, yeah. I did want to say that because I've talked about this on the stream that we did, our first stream with 𝗏𝗏.
Mm-hmm.
And I think I mentioned it last week, but because we don't have a replay of last week,
Mm-hmm.
these guys here, my like favorite tool for like gaining intuitive understanding of shaders. Hello, 𝗏𝗀𝗀𝗀. Oh, I think you were here last time. Nice to have you back.
Oh yeah, hello.
These cards, I have it on really, really good authority that Patricio is going to make some more of them. He's reissuing them.
Yes, because I don't have
talking
them.
to him. My really good authority was literally, I was talking to him the other day, and he's ordering a bunch of them to sell. So, yeah, well, right
Soon.
now they're not, but they're coming back. They're coming soon. How
I'm
long
glad.
is this going to be? HSAP? Probably like 2 hours usually we go.
Mm,
Yeah.
I would say so. HSAP.
Yeah. But if you need to duck out or for whatever reason you don't want to stay, there will be a replay. So no pressure to stay the whole time with us. We often get carried away once we get started on shaders, which we should probably do because it's 11:50. We wanted to work today with randomness, play with noise a little bit.
Mm-hmm.
Yeah.
And we don't have any big plan this time, so maybe geometries again. So
Yeah.
we will
we
come
do
up
like
with something
patterns.
spontaneous. Yeah.
Yeah. I wonder, do we want to use randomness to make the visual aesthetic or make the grid move?
I
Pattern
don't know.
move.
We can try
Yeah.
both,
Okay.
and then we see what we like. As we
Okay.
like the last time, I guess I would just try and see if we like it, we keep it. If not,
Yeah.
we ditch it. I like that
idea.
that approach. Yeah. So yeah, maybe we can start coding because, by the way, we chat a lot too. So it's not like just like coding all the time.
Yeah. Let me dip out. Okay. Do you want to start? What do we need? We have our UV. We have our X, like the XY position of all of the pixels. That's our UV.
I feel like I have to show them again the template of the book of shaders because in the last time, yet again, we didn't record.
Yeah. Well, anyways, it's nice to do it every time because
Yeah.
who knows if there's new people watching. Oh, we have one vote for noise. Cool. I think we're doing simple noise to start, like really like literal snowy white noise, chaos noise. None of the more polished noise yet. I think we want to start very simple.
Okay, I'm just gonna show them on the screen for a second. I think it changed now that you can run your shaders in different like frameworks or with different frameworks in different places, and by following the book of shaders template, we are using 𝗏𝗏𝗏𝗏. So we like to mention this, just maybe somebody who's watching today is getting started with this and don't know to even how to, for example, start getting writing shaders aside from if you would use, of course, like Shader Toy or any other GLSL editor. But if they want to do it somewhere else, maybe put it on their website, that's how you would do it. And here you get the template, so that we have in CodePen already here. And then you need to, we're going to focus on the fragment shader. Usually you have a vertex and fragment shader to parse it in, render it in your browser. But we're going to focus on the fragment, which is the pixels, the colors. The vertex.
The vertex you can use to like deform a thing.
Exactly. It's more the geometry itself of the shader, but we're going to, for now, we're still exploring the fragment.
Yeah, fragment shaders are my favorite. I did use like in 2018. I did use vertex shader. I used noise on the vertex shader part of the shader to make this bubble that I did for this Christmas experiment project. That you can still find it, I think, online. Christmas XP. I wonder if it's still up. It's very simple. It's literally, well, everyone knows how much I like bubbles if you follow my work at all. And it was like a bubble in Three.js that was getting deformed by the remix of a song that my friend did. Christmas. Is it still there? Christmas?
Vertex
I'll drop it in
shaders
the
are
chat
also
if
very
you
cool.
want to see it.
Somebody saying, yeah, vertex shaders are. So we want to explore that.
We'll get there.
Eventually, we'll get there. Yes. Yeah, you can show your. You can put the link if you find it.
Yeah, I'm gonna try and find it. Did they take it down?
In the meantime, I'm gonna tell them that the first thing that we have so far on screen in the code is the UV. It's one of the main things that you need in the fragment shader to start like painting with these pixels of color. And so far this time we already left this line of code that we been using since we started to do this collab together. And maybe I will say it again, that part of this line of code I learned it with 𝗦𝗀𝗀𝗀𝗀 on Twitter. Yuri is his name, from Ukraine, and he has a YouTube channel, very good, to learn Three.js, shaders, GLSL, way more advanced than the stuff that we do here. And anyway, I learned this line of code with him, and we kind of hacked it a bit because it's to normalize the UV that you get from -5 to -0.5 to 0.5, and we wanted to normalize from -1 to 1, so that's why we added at the end this plus 0.5. And yeah, now you can maybe create like a color so that we can tell them how to use the UV that we refer to.
Yeah, I like to do 0.5 so that we can see the difference. Let me put it in here. Great. Yeah. So here, I mean, I think he's like a magician. Yes, he is like a magician. Sorry, I'm catching up with the comments. I need to not do that because it really throws me off. So vec3, right, is the container for 3 spots. And in the RGMB, we basically did this. But you can just, if it's all the same number, you can just leave 1 and it'll assume for you that there's 3, that the 3 available spots are going to be 0.5. And so that is gray, but you know, if you put something random, I'm sure it'll be brown. It always ends up brown when I guess numbers.
And by the way, Eliza is not using
How does that happen every time?
Yeah, Eliza is not using the UV yet. She's just parsing a color right now.
Yeah, I'm just parsing a color. I have not used UV. Oh, green. There we go. So you're passing a color into this vec4, right? Vec3 is the container for 3, vec4 is the container for 4. And this is the alpha channel if you want. Will that change anything? Yeah, I don't think you'll actually see anything.
That will not, yeah,
right
at this point, it really doesn't matter.
Yeah.
Because I wanted to show them what happens when we pass the UV into the color.
Yeah.
So that you can see that you can use the UV as well to paint.
Yeah. I love painting with UV. It's always so pretty, the cascade. Yeah. I think it'd be more purple now, no? Yeah.
We'll see. Yeah.
Love it.
Okay. So.
And see, so the darker corner here at the bottom, I think if we take out the 0.5, it gets moved to the middle. I think that's it, right?
I think it's gonna be.
Sorry, yeah, the big square gets moved up. The point in the black is, yeah, just to show you what the 0.5 does. It repositions
this light kind of.
All of the pixel positions get stretched to different spots. Cool. Okay. So let's see. How do we want to bring in? Do we want to make a pattern first, or do we want to just play with?
We could bring on a pattern, I guess, so that we see something more than just the colors.
Yeah. I was going to say, yeah. Do we want to do that, or do we want to make the colors move randomly? But.
Oh, yeah, we could do that too. I guess we never try it. I don't know.
Yeah. I like we usually do patterns though.
Yeah, me too. Somehow
They're pretty.
I like,
They're more fun to look at. Okay, so let's
yeah,
do a pattern.
yeah, I vote for them.
Um,
Because I think in the book of shaders and in a lot of like tutorials to start with shaders, you start by moving the colors just with time.
yeah,
But
moving the colors around and dividing up the screen space. Do we want to just create a grid with fract as per usual?
yeah, I would say so. If you want to
Um,
go ahead, I will wait with you.
fract is am I doing a float?
You could do a float, yeah, or you could do anything you want with the fract. I believe. Let me see in the glossary.
Grid. I think it takes in whatever, but I'm just thinking like fract. If I do like, oh, no, am I fracting the UV? Now I forget because I started the thing that I posted on Instagram the other day. I created a grid in a different way, and now I'm confused because I was thinking in a different way. Yeah, I forget suddenly.
I will help you. But if you're if it's a float, first of all, you will need to input only the X or the Y axis because the UV itself is a vector too. So just choose one.
But that doesn't do anything.
No, because
color,
wait,
no?
just a second. You haven't even you haven't used it. That's why you weren't seeing anything. So
yeah. No, I'm forgetting now because, like I said, I spent all week playing with like a different grid system.
I will help you. Here,
please, please
don't worry, don't worry.
I was reading a book of shaders and I was like, how do I create multiple grids? And then I started.
We can try here, for example, and then we move it to a separate variable. But first, we can try it here.
Okay.
Like, and I like to make maybe a variable for the amount of yeah, kind of. So then we can input an n here. And
oh right, yeah, that's why I shouldn't have started outside of color. I was trying to put color in. Well, I guess that would have worked too. I was thinking of it a bit inside out, as one tends to do.
And then this is gonna make squares. But if we break it into two, maybe we have like rectangles for a change, because we always do like squares. And now we can say, for example, float I don't know, grid X, and then we bring this little fract here, and so I started the opposite, first grading into like extending the color function, and when it's getting long, then we can break it into variables.
Yes.
Sometimes when you're learning, it seems that it's easier in that way, instead of just thinking first the variable and then inserting it. You know what I mean? Because normally, if you're more used to, you can go ahead and first create the floats like you were trying, and then put it inside. But when you find it hard, maybe it's easier to just increase first the function where you are, or the variable, and then break it after.
And then, okay, I see what you mean. Yeah. So just that I remember, I think I got briefly confused between fract and modulo in my head. I don't even know if modulo exists in GLSL world.
Yes,
but
yes.
It does. Okay, so whatever I put in a fract, in the fract function, is going to divide it up whether it's even or uneven. There's no remainder, right?
Let's see the book of shaders, because one thing that I learned actually with Bruno with his 3JS course in the shader chapter that blew my mind is that I normally use fract for like fractally kind of breaking things apart, and he shows his approach with modulo, And I
Well,
was like,
that's what
oh
I
my,
mean. So
and I
like
was like, wow, you can do the
modulo,
same with mode. Like, I didn't know.
but modulo doesn't give you a floating point number, right? Because it's going to be like, how many times does 2 go into 4 twice? And there's the
Mm-hmm.
modulo of that will be 0. Or, yeah, because there's nothing left
Mm-hmm.
over,
Mm-hmm. Mm-hmm.
right?
Mm-hmm.
Whereas here you put fract 5, and you're going to end up with like 5 boxes or whatever. But they'll kind of, like right now, what do we have? We have 5, we have 1, 2, 3. Or it might be my screen. I don't know. I'm confusing myself. But basically, fract has floating, can give you an answer, an output with a floating point number.
Yeah,
Whereas modulo won't. It controls for that.
I was put in the book of shaders glossary.
Yeah, I was
just
did that before too. All it says is compute the fractional part of the argument. Specify x parameters. Specify the value to evaluate. Fract returns the fractional part of x.
Mm-hmm.
This is calculated as x minus floor x. Floor rounds down, right? So x minus the rounding down. Yeah. One day I'm going to rewrite
but this is the kind of stuff that I think is fun in shaders, because it's like when we were doing the circle the last time, you have your way to do it, and I think most people do it with the length function, but you can also make a circle with the distance function, so it's just pretty much like a taste. And I would say that when you want to make a grid, it's the same as a taste. Like you could do it with modulo, or you could use it with fract. So
you can use modulo with float numbers. Fract x equals mod x 1.
Yeah, exactly.
Got it. The difference, I think, is with negative numbers. Okay.
Okay.
That makes sense. Fract x is modulo. I didn't even. Okay, wait. I'm gonna briefly look at the documentation for modulo. I didn't know that Jello had modulo. Does it use it differently than in like regular JavaScript?
No, it's. I assume I'm gonna put as well, like in the glossary.
Compute the value of one parameter modulo method. Yeah,
on screen, so that people see what modulo is doing.
You can use modulo. X is the same as x1. How many times does 1 go into x? Interesting. My mind is like doing a little somersault right now.
I totally recommend now again, since the last time we didn't record it, to definitely check out this Bruno course if you are not like already very advanced in shaders and 3S and know everything. So because it's very cool that he also gets into shaders, and he has several exercises which I thought it was fun, where you kind of see the expected output that you're gonna learn to do. And since I already know some shaders, I was trying to guess every time. Like I would code it and see, and then afterward I will check how Bruno shows to do it. And it was fun, because then you learn sometimes other ways to do things that you maybe have a different approach. So, and you can totally learn how to use modulo after that.
I'm in the modulo, in the glossary of the book of shaders, in the modulo documentation. There's a little demo just underneath it, and I was just plugging in y equals fract x, and it is exactly the same thing. My brain doesn't really understand why right now, but that's okay. I'll just keep playing with it later, and it'll eventually sink in. But cool. Why is that? Because what is that float? Is how many times does 1 go into x? Anyways.
Hold on, somebody's typing in the chat. Modulo minus 5 equals minus 5, right? Saying for instance, sorry, different. I meant
modulo. Let's see.
We could even try now. I mean, honestly, I learned it with Bruno, and then I totally forgot because I use mostly fract.
Yeah, if you open the I'll send you the link. If you open the documentation, where are you? Telegram. I'll send it to you in Telegram.
So we can just try for fun, like the last time when we tried the distance and the length function, and we saw that we got the same result, right? So
in the CodePen, yeah, sure.
Yeah, that's what I mean. Like,
yeah, we can do it with colors.
We can just try. I'm actually, if you give me a second, I'm going into my course of Bruno to actually check and remember the part.
Yeah, different languages interpret modulo differently. Yeah, that's what I thought.
Okay.
I think JavaScript might not. Where was I using modulo?
Shader patterns.
I can't remember where I was using modulo anymore. But I was using it the other day, and it was all very, very clear, and now suddenly it's really not clear.
Oh, here it is.
Always happens,
Oh, okay. So
Unity?
I'm gonna try it because I already, because as I said, I learned it when I was doing Bruno's course. That was like what, a month ago, December, and now I already like, since I'm always using fract, it's like, but I'm gonna try it here for a
Let's
second.
try modulo, yeah.
So that they see the difference.
Or not difference.
Or not difference.
Maybe it will be the same. So, but then, so we take two. There's two variables here. So what are you testing it against? One.
I will test one and see what happens.
This okay. I mean, there's.
It's the same. Do you see?
I feel like there's more white, but that could just be.
Okay, let's now comment, for example, the modulo.
Yeah.
And go back to fract.
No, it's the same. I was just being a crazy person. My 4K screen is playing tricks on me. Okay, so but what my question is in GridX with modulo here, are we asking how many times does 1.0 fit into this?
Let me read to try to explain it.
Yeah, like that's how I understand modulo, is like how many times does that number fit into another evenly. That's how I've always understood modulo. X specify the value to evaluate, Y specify the value to obtain the modulo of.
Yeah, okay, so, oh wait. No, I was gonna say something that is wrong. Hold on.
You just went out of focus.
Yeah.
You're in focus again. Yeah. The way that I've always understood modulo really is like, so you're saying how many times does this second parameter here go into this evenly? But then I feel like that doesn't make sense the way that we're looking at it right now. But it does generate the same. Wait, what if we just get rid of, I'm going to get rid of the n for a second. Maybe that will make it more clear.
Oh, then you don't have any fraction, you know? So it's kind of like when you have fract without multiplying it by a number.
Yeah.
So then it's just like you're not fracting.
Oh, wait. I need the grid Y.
I'm going to read you something that it's from, as a preview from Bruno's course, if he's watching.
Okay.
He explained it as, and he says that the modulo operation finds the remainder after a division of the first number by the second one. Because we're inputting.
Say that again?
The modulo operation finds the remainder after a division of the first number by the second one. And then, for example, he says if you have 0.5 modulo 1.0, like right now, then the output would be 0.5. But if you have 2.0 with 1.1, the result will be 0. So it's like JavaScript. Remember when you were talking about applying modulo in JavaScript with 2 and then you have 0?
Yeah, so if you have like 4 modulo 2 goes into 4 twice, but you have nothing left over. There's no extra number. So that's why, I mean, here, if we're doing UV plus or times n.
Yeah.
It was times, right? Yeah.
Yeah, it's times because you're trying to.
This whole thing, how many times does 1.0 go in here? And it goes in, I don't know the answer to that. based on what I'm seeing. That's the only part where I get confused. I'm like, we can go by. We're gonna have someone jump through our stream suddenly. Is he nervous to walk by?
It doesn't twitch. My boyfriend, everybody.
Does he know that he's like live on there? So yeah, okay, so I think I get the concept, and I think that hi Anemolo. Oh hey you, yay, thanks for joining us again. I think in GLSL the definition is x minus y times floor x over y. Yeah, I did see something about floor in the documentation. I guess I just in my head don't know how many times 1 actually goes into uv.x times n, because the uv.x times n is very fuzzy to me because it's not a thing. It's like an idea of a thing. So then I get thrown off. It's not like 4, you know, like 1 goes into 4.
Ah, that's what you meant. Okay,
and
okay.
my brain gets like really confused because I'm like, I don't know. We're talking so theoretically. This is the part of me that really wishes that I had gone to school in computer science and math, where I'm like, I would understand this so much more easily. I'd be able to accept the generalization, I guess, that we're making here. Not even, is it a generalization?
Well, I
see
see
theoretically though.
To kind of understand it, and even with fract, it's like you can assume that maybe the UVX or the UVY, if you don't multiply it by a number like we're doing this to kind of fractalize, it's like 1. And then this, when we are like, we have this floating number 5.
So the x is the exposition of every pixel.
So let's imagine that you're multiplying the UVX or the UVY by 5. So now you have 5. And for example, even if
1 goes into 5.
For example, I'm gonna remove this now.
Yes.
So that we have only 1 fract in use. So the grid X, and then you kind of see, do you see in the screen, you see kind of like 5 lines
from top to bottom.
And if we were to say, oh, I want 15 instead, so multiplying the UVX, then we're seeing more, almost 15 on screen, right? So
because how many times does 1 go into, yes, that makes so much sense.
So this is how slowly I started to kind of get how, I mean, I use fract, but with modulo is the same. You can kind of think in that way. So that...
I think for me, modulo makes more intuitive sense because I'm thinking how many times does that number fit into this thing? But when I see an equation, my first reaction is like, what is that number? But this makes a lot of sense. If you assume that uv.x is 1 and you times it by n, yes.
And actually, it might be that the only reason, for example, if we were to resize the screen right now, we're going to see all of the sudden, for example, if we had 5, we see 5 kind of, no? But if we resize the screen, we see even more than 5. It's just because with this little hack that we did with the UV, we're kind of saying that please adapt to the screen. So then it's going to extend more. But if we wouldn't have the hack, then it would be always 5, and it will kind of stretch itself and distort the 5 bars, you know, so.
Totally. Yeah. Okay. It makes sense to me now. Makes sense to me now.
Yeah.
And it's the same for Y, which is why we get boxes.
Yeah, exactly.
And it feels way more intuitive now. Thank you all for your patience.
And probably the reason why I still, I guess, like more fract is just because to me it just seems simpler equation that I have to input, for example, these 2 numbers. Probably that's the same reason probably why I use the distance function to create a circle, because it's just like less code. So, but I'm happy always to, to be outside my comfort zone. So we can keep mode today instead of fract.
What we think. I mean, it already just did change the way we think.
And I'm gonna multiply again this so that we have the rectangles. So, so just to break it half.
Stretching it out a bit. Cool.
And we can keep commented the fract here, so just as a reminder that it's like last time.
Totally.
But it was nice, kind of like to do this exploration.
Thank you guys for coming on this journey with me to understand.
Yeah, no problem. I think honestly, it took me many like iterations to kind of understand whenever I wanted to do a grid, like how do I do it? Like
Yeah, well, there's so many ways, and like especially in a situation like this where we're all together, I get worried that maybe other people don't find it so interesting if I don't understand intuitively right away how to use the function. So I appreciate
yeah,
you
that's why I
breaking it
wanted
down with
us
me.
to kind of get it, because I know that sometimes I remember being in school now and math.
Ugh,
For some
yeah,
people, it comes very like easy. Like I guess you put it in your head already, like to break the pieces of what you're doing. But for
mm,
others, not. So it's what I like about shaders is I feel like you get to understand math because you're visually with the fragments seeing what's happening
totally.
visually. So then it's more like it makes that click. If it doesn't click automatically already
Yeah.
without seeing it, you see
You
here.
get to, yeah. Well, especially since there's the cascade of different colors. If you forget, like where I was stuck before, I was like, wait, what's UV dot X? And that's like literally a pixel position. That's all you have to remember. And once you remember that and you multiply it by your N variable, it becomes way more clear. So yeah, cool. So we have a grid of rectangles. Do we want to?
Oh, by the way, hello, Anemolo. That's Daniel.
Yeah.
And he's in the
Mario, I think
US.
Mario's sleeping today. I think he's gonna hold out for the replay.
Yeah,
Sorry.
but it's
Wait.
crazy because Daniel is in the US, so it's very early for him too. He's in Florida, I believe.
Florida's
So
East Coast. That's still pretty early. It's like 6 a.m. for
I
you.
think so. So
That's
thank you
that's
for
pretty
being here,
early.
Daniel.
Yeah.
Muchas gracias.
And Imolo is in Barcelona, no?
No, Florida in the
No,
US.
Animalo.
Yeah, Florida in the
Oh, he's
US.
in. Oh, you're in the States. My bad.
Yeah.
Sorry. I think someone here from Barcelona last week
Yeah,
too.
I think Bellufre, it's from Barcelona, I believe. Español.
Okay. Cool. All right. So what do we want to do next? Do we want to add
We
some
can already
randomness right away?
we can already try the noise now if we
Yeah.
want to. Just like
Okay.
to bring this. Do you want to bring this rand function?
Yeah. I'll grab the first one, the simple one.
Yeah, Maria's not here. It's too early. I mean, it's crazy that you're here. So thank you so much.
You want the generic 1, 2, 3 noise? Or
I was thinking to use the rant of.
there's two. There's one where he takes. Well, I'll just grab.
You
The
can
first
bring
one. It's
both. I see the difference. In one, you have to create like a float number, and in the other one, a vector too. So maybe bring the one of the float.
okay. I think that this is the one that you mean. I'm gonna put it up on top. Oops. Is this the one that you mean?
On vacation in Orlando. Where do you live, Daniel? I thought you were like based in Florida. Maybe I was wrong.
Orlando is Florida.
Yeah. That I know. But I'm not sure if he lived in, or I actually don't know where he lives. I just thought he was based in Florida. I mean, I don't know the exact
Okay.
place he's kind of like.
Yeah. Okay. So I put the simplest one that I found above the main function.
Oh,
You
maybe
take
I
in-
should show them that. Okay, I'm gonna show in the
Sticker-
screen
sticker page?
where we got this function.
Yeah.
For a second. So we got this random function from, again, thank you, Patricio González Vivo, the creator of Book of Shaders. He also has this little gist that probably, if you already are doing shaders, you've seen it. I mean, I learned this as well with Akela, and Bruno as well mentioned it in his course. So I think a lot of people doing shaders is just like, you know this. And in this gist, you can find a bunch of functions for noise, especially like Perlin noise, classic Perlin noise. I mean, I'm going to put the link in the chat if somebody's curious to try this. And you don't know about this gist. Oh, I couldn't. Oh, I have to log in.
Oh, I can do it.
Can you
I'll do
put?
it. Oh, I got it.
Yeah.
Yeah.
I didn't realize I wasn't logged in.
I think I'm still logged in. Let me check. Am I logged in? Yes, I am.
I'm gonna log in now.
No, you don't have to. I got it. I mean, you can if you want, but let me see.
Just in case I wanna chat because I didn't realize I wasn't.
Oh wait, no. You put it in the Telegram earlier, right?
Yeah.
Okay, I'll grab it in there.
Oh man.
Copy. Here we go. This is the gist. Pasted it. And yeah, thank you, 𝗦𝗲𝘀𝗀𝗀𝗀. I tend to not use GraphToy very often, to be honest, because graphing reminds me of high school math, and I struggle with it a lot. I mean, I've done it a little bit in workshops before with people, but I'll prefer the colors and the spacing things out on a screen makes it more clear for me than a graph. But
he recommended us to use a graph.
Yeah,
I think he did as well.
We get a lot of recommendations.
Yeah, he did as well before, like outside the scope of this. Yeah, maybe we can tell them that we are not so much into these graphs either. Honestly,
that's what I was just saying.
I've been in workshops from people using these graphs, and to me, it still doesn't make a click in my head when I see this. Like, I don't know. Like every person learns differently, right? So I get very confused with that. It's just like it's not making. Yeah. I find it even like complex.
I think, yeah, it's like and I have so much respect and like appreciation for people who can learn with graphs, but it's the part for me that made me kind of disconnect from high school math, because I don't know what kind of learner I am, but I am not a graph learner. It makes it so confusing because I can't translate what I'm seeing on the line. It took me a long time. Like there's one graph that I finally intuitively figured out, and it was the sine, cosine.
Oh, me too.
That's actually a circle. That's actually so a circle. The day that I figured that out, I was like, oh. And then I realized that visually, when you see like a wave of a shader where it's like black and then green, the up down, the top part of the sine, that's the green. That's the top of the wave. So it's like you're going from looking at above to looking on the side. The graph is the side, and then the color is the view from above. And then my head exploded. But that's like a lot of somersaulting for my head. So I prefer to just think about it in colors.
That's so funny that you mentioned that, because honestly, it was the same for me. I mean, just last year, early February, I was in this workshop with Matt, and I will not say his last name. Yes, because I
yeah.
And he was explaining sinus and cosinus with a graph. And before that, I wouldn't use so much sinus and cosinus, not even like in JavaScript or anything else. And I remember I was looking at his explanation, and still by looking at the graph that he was trying to explain, honestly, I didn't get it. And then I had to go back home and start like practicing more because I really wanted to learn shaders and read more math. And it took me like, it didn't make the click in a second. I had to like reread it. And I remember one day I was like, oh, I finally get it. Like, you know, this aha moment.
I'm gonna post in the chat the GIF that changed everything for me. I just found it. I posted it in the Telegram for you too. And it does depend on the person, I think.
I think so too.
The more that I understand it through colors, the more when I look at a graph, I'm like, okay, that makes sense. But I think I can't do it the other way around.
Yeah, me neither. Sadly, for me, it's like, so I totally get that. Yeah.
But that's the type of situation where I become convinced, or I did as a teenager, that I wasn't a math person. And that drove me nuts. That's why I was so grateful to, oh my God, how am I blanking on his name right now? Nature of Code, Dan Schiffman, obviously, everyone knows Dan Schiffman. So grateful to him, and for the book club he did like years ago that I was a part of, where he did the summer reading of Simon Papert, I think, Mindstorms, where they talk about how everyone is a math person, and you just have to find your way of understanding this invisible, natural kind of language that exists in the universe, and it doesn't have to be on graph paper or with a calculator. Like it can be through, you know, visual explorations. And I was like, okay, cool. So I am a math person because I find this stuff really interesting, but a graph doesn't do it for me.
Yeah, me neither. This is so crazy. You know, we have that other thing in common.
Yeah, well,
Oh,
yeah, it's true.
Yeah.
Eliza and I have a lot of overlaps.
Mm,
A lot of overlap. It's very funny. Everyone has a doppelganger, right?
I know.
Apparently. I found mine finally.
Yeah, me too.
Thanks to a shader workshop this summer.
From Canada to
Virtual
Mexico.
doppelganger. Macchio, same here. I had to force it into my brain, and one day I was like, oh, I get it. Yeah, totally.
Yeah.
Have you signed for a long time, but that GIF. Yeah, I'm glad you appreciate that GIF. Yeah, that one really blew my mind.
The aha moments are amazing, honestly, when one is trying to understand math in like, computer programming. So I must say, because sometimes you just use the stuff that somebody tells you, oh, you can do it this way. And then maybe, and I've done that. I'm lazy and I'm just like using this thing that somebody showed me, but I'm not really like digesting it. Exactly. But when you finally do, it's like, oh, that's why.
I used to be really hard on myself where when I would have the aha moments, I wouldn't even celebrate it. I'd be like, how did I not understand this before? How am I that dumb?
Yeah.
And then I was like, no, that's so silly. Your brain and your body are internalizing a thing and integrating a thing. Like that's a good thing. That means that you learned something. And now I'm much less hard on myself. But yeah, math trauma, man, it's a thing. Anyways, let's play with some randomness.
Yeah. After all
Sorry for the tangent. Is this the function that you were talking about, the one that I posted above?
Yeah, it's fine. Yeah, we can try that one first.
So we send in a float. Would we want to send in the grid?
I was thinking, since it's a float that we have to input there, it means that we could use it, because we have only floats in grid X and grid Y. So
n equals plus equals? No, I guess I would just here. I'm always skipping one ahead. I don't need to do that. I can just do this, right?
Well, I don't know. Try.
Okay, so that just randomized the color and got rid of the grid. That's not what I was expecting. X and a float.
Try to multiply the 5 against maybe rand and maybe put the time inside.
Ooh, I like that idea. Okay.
And maybe we might see something like.
That's what I was expecting to happen when I wrapped.
Scissors? Yeah. What's this word in English?
Seizure. Sorry. Yeah, we should probably
we
times that by 0.05 so that it does not give anyone seizures. That's not. Did I do that in the wrong order?
What did you do? Sorry, I was watching the chat. Somebody's comment. Okay. Mathematicians are people who can really. Yeah, I agree. I have so much respect for mathematicians.
Yeah. I have so many books on math that I love to read, but the types of books that really explain things like theoretically without any actual like calculations or numbers, and I find it so fascinating. But all of the not the equations, the formulas and stuff that you see with all the Greek numbers really throw me off. I was trying to slow down, but that's what I was trying to do. Yeah. I'm
gonna try to put sin.
Yeah. Maybe, and then we can slow it down. If I put times 0.05, that should slow it down, no?
I would.
No, it doesn't. Interesting.
What about? Yeah. Hold on. Normally times.
It's because it's really fast in the rand function.
It already has sin actually inside. Now I see that.
0.5.
Oh, you're like, oops, sorry. I think now.
Okay, I slowed it down.
Okay,
but cool. I slowed it down in the.
Yeah, that's fine.
Function. I don't need to slow it down that much though. No, that's still too much. But this doesn't feel so much like noise anymore. This feels like a regular sine function. I'm going to put it back to what it was. And if anyone has any like trouble, let us know with the speed at which everything is changing on the screen.
Yeah.
Oh, we got a heart. Mathematicians are people who can make really weird associations. Among them are the qualitative and quantitative ones. Yes, exactly. This is why I love reading about math.
I'm gonna
It's all
try it somewhere
weird.
else.
Yeah. Feel free to plug and play. Notice rand returns a number from 0 to 1.
I was thinking to put it in the grid, maybe. Here. No, wait, where was I? Here. But maybe it's gonna, is it gonna be the same effect?
Right. Rand returns, so you're fracting.
Only the light, kind of.
Cool. Some strobe light.
Obviously, okay.
Yeah.
And now I'm gonna try to do color equals rand.
Do we wanna do something with rand so that it goes from -1 to 1? I don't know. Because right now.
Oh yeah,
goes from
color is
0
a vector 3. What am I doing?
Did you put? And
Yeah, I
also, no,
cannot.
but you put time and not use time.
No, wait. Ah.
There
Right.
we go. That's what I was. Yeah. Okay. When I think of noise, this is what I think of.
Yeah.
Can we add or times that by y? Yeah. Yeah. So if I do.
It's so interesting that the timing when it's only lines, like on the screen, it doesn't kind of feel so terrible as when we were in like noising the grid, you know, that it felt like.
But the grid is. But I think if we did vec3 to layer them, we need a multiplier, right? So if I did. I did that times x. Would I get the line? Yeah. So this also doesn't feel so jarring to me. I think it's just because of like the size of the grid, I guess. So if we made the grid smaller, it would probably be okay. It would just look like large pixels. So if I do that, and
I made the grid smaller.
Yeah. So you made that no, I mean bigger. Sorry, my bad. I meant bigger. Whoops. So if you put this at like 15, I meant the size of
that would be a lot. Sorry.
Okay.
Now it's 85. That's too much, I think. So.
No, but wait, because if we add, where did you add it before? Here, we added it here. So I think that this, is less jarring. I don't know if it's making your computer melt. No. If it is, we can definitely. So like 15. Yeah. Still easier on the eyes. By the way, Freya has a lot of awesome. Yeah, Freya. Love Freya. I'm obsessed with Freya.
I've seen Freya.
I'm not sure. She did. They did. I don't know. Freya did a 3-hour like intro to shader and Unity thing that I loved. I think I watched it like 3 times because I do shaders. I do more complicated, or not complicated, but like 3D shader things in Unity. She's awesome. Okay, cool.
By the way, hello to Nerdisco and okay, bye. 2 new people, 2 friends coming in. Hi.
Oh, cool.
Thanks for being here.
Yeah. From her gifts, but also check out her she puts like, I think she actually live streams on Twitch a lot of the courses that she teaches to
She's
students.
also on YouTube, I think. I feel like I've seen
she puts
one.
her replays on YouTube. That's the thing.
Okay, because I've seen her on YouTube, but only once. I have to check her more since everybody's recommending her now.
But she does mostly stuff in Unity. Just so you know.
Okay.
Yeah.
Okay.
But the math stuff that she explains, you can port that knowledge into anything. Her explanations are amazing. She's incredibly eloquent and doesn't speak too quickly, and also just like smart and knows so much math. It's wild.
Oh, cool.
I'm always very in awe. Whoops. I'm deleting something. Of people that are so much younger than me that know so much more than me. Oh, okay. So we have some noise. I don't know. What do we want to do with it?
Yeah, it's too.
This is why my favorite type of noise is like Perlin noise, or what's the other noise that I use?
We can try to bring those in.
Yeah?
Yeah,
okay,
because we already tried this one, but this one is not. I'm gonna kill it because
thing with noise, right?
My head was like.
Perlin noise. Back to fade. Classic Perlin 2D noise by Stefan Gustafsson, which is the one that I've seen pretty much everywhere. So I'm going to copy it. It's a big, kind of big, scary function. I'm going to put it underneath rand. It's huge. That's a large function with a lot of things happening in it. But it takes a vector too, so we could pass in the UV if we wanted, and then just have some pretty colors maybe floating around on the screen.
Wow, that's a hell of a function. But I love that people put this honestly out there for others to use, because I wouldn't be able to come up with such thing on my own using pi and permute. Oh my god, wow. Thank you.
I mean, I understand, like there's abs in there, floor, norm, dot. I know what all of these things do independently. And a mix, there's your favorite mixes in there, but not for colors. I know what they do. I wouldn't know how to combine them in this way.
Yeah,
but I do understand the concept behind Perlin noise as well, which is like you're finding a random-ish number, but that's close as possible to the previously accessed number, right? Instead of what we had before, which was like literally anything, anywhere, which is why everything was so like all up in your face.
We are recording, Daniel.
We are recording now. Yeah.
We triple checked
it as we were streaming at the beginning. Okay, so how do I want to implement this? Shall I try and pass in the UV?
Yeah, try.
Why did it stop working out all of a sudden? Is it still working for you? No, the screen is black.
Ah, yeah, true. It stopped working. Are you missing something maybe?
Maybe
that function is using something that you need to bring in here.
I didn't implement anything yet though.
No, I know, but sometimes those functions, like for example, in the noise algorithms that we were, hold on, let me bring that back. For example, did you take that one from the gist? Because sometimes, for example, if you want to use the noise one, you need the previous function above that one.
Oh wait, there was one right above it.
So if there was one function, that's why kind of he puts these blocks, and if you want to use the last function in each block, then you need the previous ones, otherwise it's not gonna work.
Okay, let me try and recopy this properly. I'm gonna delete it, see if everything works. Yes, okay, and I'm gonna repaste it as it was written in the whole block.
Yeah, now it's cool because now you brought in the previous function. Perfect. Yeah.
But for me, it went black again.
So, oh wait, yes, true. But you got everything from him?
I got everything. Classic Perlin 2D noise, the whole block. What's in there that could be causing a problem? Let me comment out the grid.
I'm gonna comment out the run function. I don't know if it shouldn't. I mean, oh, I know what.
Why?
Wait a second. No. I thought, but he created his own pi, didn't he? Yeah, he created his own pi. I thought maybe we needed to put pi from it. Yeah, why is it not working for us? This is weird. Because I can see that you put everything.
I did, yeah. So let me comment out the grid for a second and just put like a regular old
I don't think it has to do with that. I am sure it's a function that is missing something.
Let's see. Just like to check in case, but you're right. I wonder what it is. Is there a simpler function that we can use maybe in that case? Because
There's another Perlin noise here. Why
it's
don't we
3D
try to
though.
take the first one?
I did take the first one, didn't I?
No, you took one called classic Perlin noise.
Oh, my bad. Yeah, you're right. I went too far down. Let's do that instead. Here, I
Take the
grabbed
first
it.
one, which takes
Yeah.
the run function with the
Yeah,
vector 2.
I went a
don't
little
know.
too far, too fast,
No, it's
as,
fine.
as I
But-
usually do.
Because I cannot debug quickly right now that.
No,
So.
same. But again, no.
Because I've used one of them. I think that's the one that I've been using.
Don't need that. You're right.
Or the one with hash. Hold on, because there I was trying these Perlin functions the other day, and there was one that makes the Perlin function with, you can actually see the triangles, like the so, and that one I don't like because then it's not so smooth. And then there's this other one that uses a hash function to make the random, which is more smooth. But I'm gonna have to check in another code pen that I have. Private.
Let's see.
Random. I have to.
Oh, you want the?
I'm looking because it's a long time I tested this here. Here it is. Yeah, it's this one.
Let's see. I can always try.
Did you try to input the first Perlin noise, by the way?
Mm-hmm.
And that didn't work either?
No. Let me try
that's
again, but let's see. So now everything works again. And I'm going to paste that first whole block. I'm going to comment out this rand, the top one. And then it does not work. Why? The whole block.
Okay, now I'm bringing something else. Yeah, now it's black again. I'm gonna delete that and try this one.
Sure.
That I have here. This one doesn't kill or screen. Okay, cool.
Oh, that's the hash we were talking about.
Yeah, okay. It's basically it's randomizing, but and it's from this 𝗦𝗲𝗀𝗀. So thank you, Morgan. But it's also in that gist from Patricio. It's in the gist. Yeah. I took it from there.
Yeah, I think I saw that hash when I was scrolling through as well, but it paired with. Where did I see that?
If you look for his name, 𝗦𝗲𝗀𝗀, and
I see it.
Then you find it.
It's just above the Perlin noise block. Are you taking all of these functions?
I only took the noise one. So,
okay.
So that
that works. Okay, so we have the
But we needed the hash for the noise one to work. That's why I had to take the hash, because the noise one used this.
So I wonder what the difference between this and rand is, or what the difference between this and Perlin noise is then. Let's see how it looks different. It takes in vec2x, so we could do, I don't know, do you want to just throw the UV in? Into the vec2?
I'm gonna, hold on, I have to go. Yeah, where are you? Where are we? Okay.
I am just hanging out underneath the float.
Yeah. So I was gonna bring in, I always bring, because I forget otherwise. So let's see. We need to use a vector 2.
Yeah.
So sometimes it takes me a second as well to like grab this function and then like
know where to. Oh, I see. We could do. Wait. Okay. So
In the
I have an
color.
idea. I have an idea. I'm gonna stay where you are. I'm gonna comment this out for a moment, and then I'm gonna copy and paste it again, and then I'm gonna do. What's it called?
Oh,
Noise.
cool.
UV. And then I don't know what that number is. 0.5. That's RGB. Blue. Is it gonna do anything? No.
No.
It will do nothing. Why? It's taking a vec2. Should do something with it.
Yeah, I
no
follow
idea
you. It should.
what it's doing. Is it because of this 0.5? Maybe put it back to.
Let me see how I use it. I can't believe I forget so fast. How did I use it?
I'm like I think I said before we started streaming, when I use noise, it's most often to make my objects kind of move around in 3D space, and so using it to control color right now is like mind bending for me, which is funny because it's in a 2D situation, so I feel like it should be more obvious, but it's hard for me to switch context like that.
Yeah, me too.
Modes of thinking.
And now I'm thinking if maybe we need to actually create, because since
outside
it's
of the it's a vec2, no? Oh wait, what is it? Oh, float gives us a right.
But it doesn't make
That's
sense
why.
to me.
No, that makes sense because no, that should still give something because it's giving you two floats in that case. We're putting the same float in two positions.
For me, it doesn't make sense what I'm trying to do, but oh, sorry. I'm gonna
vec2 noise.
It's still nothing is. No, now I see
noise
something.
returns a number in
Now
our
there's
vec2.
something.
Yeah. Yay. Yeah,
Okay.
vec2, noise mimetic returns a float.
Yeah, that's what I
vec2.
did. So I created a float variable because I was looking at how the function was. This is how kind of for the ones that I'm watching, if they want to like see how we digest this.
Yeah.
So I look here that the noise is a function based on a float. So I thought, okay, then let's create a float noise variable and then use it. But you have to parse a vector2 inside the function, not a float. So
yes.
And then it worked.
So when I plugged it in, I would have had to put this twice. This is better notation, but that's why it didn't work. That's why I was like, what's going on? Because I was looking at the float noise function. I keep forgetting you guys can't see what is on my screen because I'm not the one recording this, but basically I'm highlighting the float noise function takes in a vector2. So in my head, it spits out a vector2, but no, it does not spit out a vector2. It spits out a float.
And
so
here's where I wonder, hold on.
What if we
I was gonna put instead of the UV or grid because it's as well. So
okay, look at
it's fine. Leave the because then we can see the color.
To wrap it in a sign though, because or else it's just gonna go white. No, but yeah, this is fun with the noise. It makes the like lava lamp effect kind of.
Yeah, that's why I want to put the grid to see, because I don't actually can see the noise right now.
I'm into it. Let's try that. So
why are you not liking that? Because I have to say vec2. Are you kidding me? Seriously?
I don't think you do. Oh, maybe you do. Yeah. Oh, types.
Yeah, you have to. Fuck. This is one of the things of shaders that I have like a headache that you have to. Why?
But it's good because it makes you understand, really know what it is that you're.
Yeah.
It makes you really think about what you're trying to do and why it works the way it does. It just takes so much longer. JavaScript has contaminated our thinking. Try U time inside noise.
Yeah.
Inside noise. Ooh, okay. I like that suggestion.
Mm-hmm.
I was going to say, now we have a grid that doesn't feel very disorganized.
But it's different colors. Do you see
Yes,
that the
that's true.
grid has different colors now?
Ooh, okay, wait, I should probably wrap this in a... Always wrap time in a cycle.
Mm?
That also looks
And I
weird.
made like bigger, just so that we can see the movement.
Yeah. Okay,
Maybe
wait.
even maybe even bigger for a second.
Yeah. What part is the noise?
The noise is,
The color distribution?
I would assume so, because when we had the
Bruno, we are experimenting with noise. We are just we're playing around with noise. Sorry, Bruno just jumped in the chat.
hello, is that Bruno Simon?
With
Bruno?
no. Bruno, no.
I
Is
think
that the
he
same
is.
Bruno as last week?
I don't
But
remember.
yeah, to catch you up, we were playing with noise, just trying to like understand how to use it with, or like what it's doing based on the things that are happening on the screen.
Trying to understand.
Yeah, we started with random. It was very messy, and now we wanted to do Perlin, but the function was being problematic. So we're now using who was the guy that did this function? Morgan McGuire. Sorry, Morgan McGuire's function for noise that you can find on ShaderToy. There's also a gist that we posted further up in the chat.
Yeah. By the way, Bruno, since you're here,
Bruno knows the gist because he used it.
Yeah,
in his course.
exactly. I was gonna tell him that I already like did a shout out to you on your course, because as you see here, we use modulo, and normally we don't use modulo. We use fract when we want to do a grid. But I was telling the people that I learned that with you in your course, and it blew my mind, because I didn't know that you could do like fract or a grid basically with modulo. So you missed that part. So
yeah, I like modulo a lot. To me, modulo, like I was saying before, it feels more natural, because I'm like, how many times does this number fit into this other number? Then fract, I'm just like dividing something up, and then there's all of these leftover bits and pieces of everything that you divide, and then I get kind of overwhelmed. But to implement it before was a trick. It was tricky, so I appreciated.
Yeah. And by the way, he's saying that he wondered the performances. This is the same question that I have, by the way, Bruno, because we were saying that the last session when we were making a circle, like most of the people use the length function, and I like to use the distance function, and you still like create a circle with both functions, just like with modulo and frac, you can do a grid. But really, that's the question, like, would any of those choices would be more performant in the end? So that I have no idea. If somebody ever has, it would be like good to know if there's actually like an advantage of like doing it in a certain way than the other, or if it doesn't really matter and it's just a matter of a taste. Just like in mathematics, sometimes it is now that you can achieve certain goal in with different equations, no? So.
I wonder if to the mathematicians in the room, is math like code in that like there are a million ways to go about doing something, and everyone's way of approaching a problem is kind of what decides? I mean, if you take out performance from the mix, is it really like? Do you know what I'm asking? Do you know what I mean, Eliza?
I think but I think it is
a code problem totally differently,
because
even to like lay out a web page, you know.
I was just thinking like math in high school or university. So whenever we had like tests of like, I don't know, matrices or fractions, or I remember sometimes two people like having the right result kind of that you were seeking, but we did it differently. Like one person maybe
that's why they always make you explain your answers, right? You can't just like write the answer if you know it. But my math at my school was not taught like everyone has their own way of doing it. Math at my school was like, this is the way you do it, and if you don't do it this way, you're wrong. Which is why I was so turned off. Yeah.
Okay.
Yeah.
I mean,
no, it wasn't
I guess it depends. In some places there was one way to do it, but in others, you could like just be creative, I guess. And just like find the result in your own way. So. Yeah, that's weird that they were like that in your school.
I've been very for the most part, which is crazy because whenever I think of school, I'm always like so inspired, like I want to go back and study. But in my experience with teachers, I have not had the best of luck. But I have friends who've had really inspiring teachers, which always makes me feel like I just ended up with a random bunch of less inspired humans at the helm of my classes. But
Yeah,
so
'cause, by the way, speaking of teachers, I believe that sometimes like people can be an expert on a topic and then they can be
and not
brilliant,
know.
but they
Yeah.
cannot be teachers. You know, like when they try to explain things, it's just like you don't get it. And I think it's not as easy to teach because even if you have the knowledge, so it's just that's what I perceive. I mean, since I was in school, like you were saying, I used to have teachers where I didn't understand anything of the subject, but I think, and maybe sometimes we used to blame when we were especially like teenagers, like, oh, I'm not good at that, but sometimes it might not be that. It might just that the teacher wasn't good, really. So
No, or uninspired. Maybe they've been doing it for too long. I don't know. And I'm sure it's different if you're teaching the same course for like 20 years of your life to a bunch of 14-year-old children who really don't want to be in the class. But when I do workshops, I tend to have, and I'm teaching like programming and stuff, I tend to have a no man left behind policy where like if someone comes in and knows a whole bunch of stuff, like they'll be happy if they learn like one little new trick and they can entertain themselves, right? Whereas the kids who come in, not kids, 'cause I
right.
rarely teach kids, but like the adults that come in and who are like really overwhelmed and feel completely lost and stupid, I tend to try and cater to their knowledge base expanding and their understanding expanding so that they feel empowered, because or else it's just not fun for them and they feel stupid compared to the person who like knows all the things. But not all teachers are like that. Some teachers get so excited when like really advanced students come in that they completely disregard the beginners, and I find that so unfair and just like not good teaching as a strategy. Anyways, I see something happening in the chat. What's
Yeah, I
happening?
was just reading like it's just a friend team was asking me if I was talking about another friend, Gregor. I wasn't. I wasn't really talking about Gregor, but now you're talking about him. So it's Gregor is an amazing dude. He has like he's a genius in mathematics. It's just crazy, like the stuff that he's doing. So and I think he was just now talking about that.
I love a good genius. What
Oh,
did you
he's there. Okay, sorry. No. Hi, Gregor. He's there. Okay, yes. So he's a genius mathematician, and I think now Tim was probably saying if like Gregor is a good teacher or not. So.
Is he like? Does he put stuff out?
Yeah, but he's no longer online. I think he wanted to take a break from like the whole online world, and
Yeah, fair.
you cannot find his work sadly. But 5 years ago, he used to have this nickname on like social media, Twitter, and he was doing a lot of code pen too back then, Pixelas. So I don't know if that ring a bell.
Okay. Yeah, definitely.
He was
Cool.
very prominent actually, because
Well,
the stuff that he's doing is just literally like crazy. So
maybe one day he'll feel like coming back to the online
yeah,
world and
maybe.
sharing his knowledge with us all.
Mm-hmm.
Thanks for watching, guys.
Yeah.
And I wanted to ask, because Mimetique said something in the chat about math. What do you mean by lateral thinking? Because he's saying math is all about lateral thinking. I don't know what that means. I know what linear thinking is. Lateral, I don't know what that means. So if you feel like explaining that, feel free.
I think lateral means that you can have multiple solutions to a problem.
Is that what it means? Ooh,
Please,
I'm
somebody
all
in
about
the
that
chat
then.
say if
Lateral.
I'm correct with this definition, if you're still tuning in, if that
Lateral
would be...
thinking, according to Wikipedia, is a manner of solving problems using an indirect and creative approach by a reasoning that is not immediately obvious. What?
Okay. So
They need to explain that better when they teach kids math in school, because that's not the way they make you feel when they're like, no, this is wrong. There's only one way to think about it. Okay. Clearly, I'm a mathematician at heart then.
Yes.
That's definitely my approach to all the things. Cool. Cross-pollination. Yes. Hoodie Robbins. I like that
hello,
name.
Hoodie Robbins. I think this person is new. I've never seen this.
I think so as well. Or he's just been quiet, or he, her,
Yeah,
they,
she,
just been quiet, she,
whoever.
all of the
Pronouns.
all of the pronouns. So I don't know if you noticed, but I put a sine and a cosine on the grid just to see if that makes the difference. And I'm still wondering, is the noise that we implemented affecting the color? Are the color, just the way that the color is in the screen? Because obviously the changing light or whatever right now is because of the sine and the cosine. So is the noise what's deciding about the color?
I believe so, because when we didn't have the noise, we have different colors on the screen, you know. So
Right. So if I
and now it's yellow and blue, which is an interesting combination because we both like these colors. Do you see this?
Yeah. That's funny. Oh, okay, wait. So then my usual thing that I do, dot x plus dot y, then we should get the line across, no?
I think we're just talking about color here, so you're not going to see any line, but I have an idea.
No, not like a literal line. I mean, just like instead of it being blue down to yellow, now it's like blue down to yellow.
Okay.
Very technical way of explaining things. Yeah, okay, that makes sense.
Because the other idea that I had is that we could create colors like last time.
I was thinking the same.
And then kind of input it to see how it actually affects this like UV colors, right? So
yeah, but just to say UVX plus UVY just gives you the average of all of the
like the rainbow,
which is why
spectrum.
It goes from top to bottom. Yeah, totally. Okay, well, my usual color is going to be yellow.
I'm gonna grab a glass of water. I'll be back. I always have to drink.
Step 3, yellow equals like 3.
I noticed that you don't drink much when we speak. I don't know why when I speak I need to...
I do. I come super prepared.
Okay. Because I'm like, I feel like my mouth gets dry, you know, because of the speaking. So
I think I do when you're not looking, but I definitely do. RGB, right? There's no blue and yellow. Enjoying following along first stream for me. Oh, well, glad that you're here, Hoodie Robbins. So I got that right, mimetic. It means, so lateral thinking, it means that you don't solve the problem directly, but wander around and explore possibilities that seem unrelated, but get where you, dude, that is the story of my life. Okay, like literally, I'm totally a lateral thinker. It's true. My mother has often been like, you take the most roundabout ways and the most confusing ways to get to where you want to go. And it's very true. Very famous mathematician used to say that one way to open a nut
is to direct
the shell. Another is to soak the nut in water for so long that at the end it opens itself up. It's a nice metaphor for lateral thinking. I'm going to screen cap this. I need to put that on Instagram later because that's a very inspiring quote.
Screenshot.
Cool. Screenshotted it. Hope that's okay, mimetic. If you don't want me to tag you, I can obviously.
Who's the famous mathematician mimetic, by the way? Do you know his name?
Arius. Do we know his name? I'm sure if we Google like walnut.
Probably. I was just wondering if he knew to type the name.
I'm going to make you a color. I'm going to call it C1 because sometimes I like to play around with the colors afterwards. And then I'm going to say that we want a purple or something. I think red and blue.
I actually wanted to make purple, but I'm going to enter a different...
Yeah, you know the colors better than me, but these are our
and I'm going to comment here for now, purple. And here, yellow. For the people that is maybe watching and are wondering why are you like doing colors like that, or how did we came up to like those numbers, is because purple, for example, in RGB would be 50%, 50%, and then you kind of transform that into decimals like here. So that's the way that I personally work with colors on GLSL, that I just look for the RGB of that color that I want to, and then just transform it into decimals. Yeah,
Cool.
that's it.
I was just taking a screen cap of that because we got the name. The name is 𝗦𝗲𝘀𝗀𝗃.
Oh, okay.
I'm going
I
to say
didn't know.
maybe German or Russian or Slavic or something.
From Holland, maybe?
Holland. Could be Dutch.
Sounds
That
a
would be
little
hard
bit,
to pronounce if that was Dutch. That would be like,
yeah.
because the G is like h. It would be like 𝗏𝗀.
Sounds like Dutch
I don't
to
know.
me, but yeah, who knows?
I'm butchering that. I'm going to stop.
And then it's gonna be Russian, maybe.
I think
Completely like different. Who
I'm
knows?
going to Google that. If you feel like plugging in the numbers, you can.
Okay, yeah.
Very
Google the
awesome.
name and then let's figure out where he's from.
Oh wow, I'm very curious. Alexander Grothendieck was a mathematician from Prussia, Berlin, Prussia, Germany.
Ah, okay, so not even. Okay, so
He looked
German,
like-
kind of.
And then he was French. Hey, cool. I'm French too. He passed away in France in 2014. Oh, he lived through some
not so long
interesting
ago.
decades, man. He was born in 1928 and he lived all the way until
Oh,
2014.
shoot. How many years was he then?
86, but that's like a
Ah,
lot of
cool.
wacky decades. That's like two world wars, I think. No, one
Plus
world war at least.
technology.
That's the end of a world war, a new world war, Vietnam, the wall.
He lived
that's
a lot. Yeah, he lived a lot.
That's a
Plus
lot.
technology. So crazy.
Oh, and the picture that's cute. I feel like that's I love. Okay, I mean, this is not serendipitous at all, but it feels like serendipitous because the Wikipedia picture is of him in Montreal, which is my hometown.
Very lovely city, by the way.
It is a lovely city. I recommend it to literally everybody. It's super fun. Not obviously currently, but in general. Okay. Back to our lovely.
Oh no,
Craig.
wait. What am I doing? That's a big 3. Sorry.
Now we have some pretty colors. You put in your color only or mine too?
I put only my color, so we can add yours too.
Okay.
So
To like that, or do you want to do a layer?
I was thinking, let's see
Now
what happens.
we're mixing colors.
Yeah.
Like a poopy pink. I don't like that so much.
I like that.
You like that shade? Oh, I do
Okay.
like it better than this. This is not nice. Okay.
Oh, okay.
Do you want to
I
do
wonder-
a mix, maybe?
I wonder what happened. I was gonna say, yeah, you can try that too. Yeah, because I wanted to try like. But
Did I do
you need
that?
a third value in mix,
Oh, yeah.
like the interpolation.
I was like, at the beginning, no?
No, at the end.
At the end, my bad.
You put what you want to mix in together, and then the interpolation.
It's the opposite of smooth step.
Yeah, you could use the UV as well. Try
Ooh,
to
I
use
that
like
idea,
the
yeah.
one of the UV axes and see.
Ooh,
Yeah,
I like
because then
that.
we see more like a spectrum, no? So, and if you use the UVY, I assume that it's gonna be the like instead of like this, right? So
Yeah. And then if I want it to be the average of those two, I can add them together.
yeah, which is
Ooh, actually, that's not so nice. I don't like that. I think
no, I like
prefer-
more when it was either Y or
Yeah.
X.
I like this one because it's like a fire or something.
Yeah, and
Um,
if you would like to invert it, yes. But I think it's 1 point. I think it would be 1 point minus.
Oh, that's your trick that you're always doing. Why does that work that way? Oh, right, because you're right. No, that makes sense to me. That does make sense.
Then you invert. You see the
Took me a
yellow
long
at
time
the
to figure that
bottom.
one out.
This is
you-
a very nice trick that I like when I wanted to invert the thing or the color that I have on the screen, just like 1 point minus, and then it like.
When I don't think of it in terms of color, I find this trick really confusing because I've done it before in like Unity to space things out and stuff. But with color, it makes so much sense to me because I'm just thinking of like 1 is white, 0 is black, 1 minus something is somewhere in the middle. Yeah. don't know why it always comes back to color, but it is so much more clear to me when it's color.
I mean, you can remove it. I just wanted to show people like watching beginners that
No,
you
I
can.
like it. I like that a lot.
Okay.
Mimetic says his main goal is now to survive a Berlin winter with no bars. Yeah, dude, I know. I lived in Berlin for a year. The winter was tricky because the sun starts to set before it actually gets to the top of the sky. That blew my mind. Blew my mind. I like the sun going down at 4. I grew up with it that way in Canada, but we have snow there. So when the sun is shining and everything is covered in snow,
And here's
so
no
bright.
snow, so there's no
happy.
prettiness because the
No.
snow gives light too
No.
from like
And
the light
Berlin
city.
does cozy really well when the bars are open. There's like candles and like bars with like little old, I don't know, in my memory anyways, but I lived in a very specific part of the city. But like, yeah, like ratty old sofas and like gigantic German beers. I don't know. I don't know what it's like over there now. But
I feel like him, like I would say that the lockdown on winter for me, it's harder than if it would be summer because I wanted to, for example, to run and I can't. Right now it's so cold for me that I tried it like last week and it was just freaking cold. Like
I saw an ad. I'll send you a link. I saw an ad for thermal leggings. And I was like, Ilithya should get these for her job.
I have all the freaking equipment. I spend so much money, honestly. But my problem, and I don't understand how people do it because I see it like even my boyfriend goes to run, is that the freaking air that comes into my nose, into my lungs. That's when I like, even if I'm wearing all thermal and everything and I'm covered up, just like breathing is too much. And then I try running with the scarf. Which is a sports scarf. No, it's not like a very thick one. Over, one. But then it's you cannot really run. So I don't know. But this has been my problem since I moved to Europe. Like even without lockdown, for example, biking, I could never do it. Like on the winter too. I don't know if it's just because the way I grew up in Mexico that I never grew up with cold weather. That my body feels that it's not.
Probably.
Ready, as opposed when I see Europeans here biking still, for example, right now when you have like 0 or below and they just go,
if I have gloves, I'm good. If I have I'm picking up my bike next week, actually. I'm very
cool.
excited. I used to live in HH. What's HH?
Hamburg. Oh, cool. Are you a Berliner or a Hamburger or where are you? I'm guessing Mimetic Music is a German dude. Cool.
No, he's Italian.
And
he lives in Berlin, I think. Right?
Okay.
In my memory, he's from Naples, which is like my favorite city in Italy.
Interesting. So he's a world traveler as well. Cool.
Yeah.
Yeah,
I feel like everyone in Europe travels though. That's why I stayed here when I moved here from Canada, because everything is so close. So you could just like travel anywhere all the time. There's like a train anywhere you want to go.
Yeah, everything is so, I suppose, in America, right? So when you want to go to a different country, it takes forever.
It's going to cost you like so much money just to get across the water. And
exactly. Yeah, and in here you can jump. It's really nice. Not only cities, but as well like countries. So.
Yeah.
Right.
I have a question.
Yeah.
You know how last week we used, how did we do that? We made the circles kind of like open and close, but not all at the same time. I wonder if we can do that with like the size of our cubes, but with noise.
Okay.
You know what I mean? So we see the noise more in the shape of the square.
Yeah. Like but do you mean like, do you want to make them smaller and then like bigger?
Like breathing, I guess. Yeah. Bigger and smaller.
Yeah. We can try to do that. Yeah. Because now I'm really happy how the kind of grid looks.
Good.
Yeah, it's really nice. I really like the light going on in there too, like switching between. So that's very pretty.
Getting like 4 p.m. on a sunny day in Paris vibes.
Exactly. That's how I like to call it, almost like sunset. Is it sunset?
Hamburg apparently has worse weather than Berlin.
Yeah, probably. It is true. It rains a lot in here, which is hell. Like last week, it was raining a lot, and I hate it.
Really? I woke up
prefer
to like
snow.
lots of rain this morning.
It's kind of like in the States, Seattle, kind of, or London.
Oh gosh. Yeah, I
in
used
the
to live
UK.
in Vancouver, so I know that weather well.
So it's very like London in here too, like rain and like when we had snow, it was the kind of snow that it was melting when it goes like down in the floor, so which sucks.
Really? Yeah.
But other than that, the city is very pretty, I must say. I really love Hamburg. So
I haven't been. I want to come one day.
you have to come so we can
Yeah.
meet. I would love to visit you. But yeah,
It's true,
you
we've
have to
never
come.
actually met in person. It's so funny about this friendship.
Yeah, I know. I can
Um,
imagine a lot of friendships nowadays, especially since like the whole pandemic, right? So like a
Yeah.
lot of people meeting online like this, and yeah, you don't get to see each other
I
yet.
mean, I did it in school when I was in high school, way back in the day. I would meet boys from like other schools on ICQ, and then we would like meet in person months later and be like,
Yeah, true.
you know,
Mm.
the early internet days when it was still kind of relatively safe.
Yeah,
I wanna say.
crazy that when you were mentioning, it was the same for me when I was a teenager. Like when the internet was like, it would be exciting, not to meet like people.
Yeah, be like, sign my guest book. I'll meet you in person one day for a coffee. Oh my God, the
Oh
guy
my
from the other school signed my guest book. Oh man. Okay, so I'm trying to think in my head where we would put noise to make because it's you get back.
Yeah, I'm trying to put my
Get
head
back
again in the
low.
shader.
But we give it a UV.
Um,
So if I what if I did like float test, because I am terrible at naming, and then I did noise UV, and then I did test, 'cause it's a float, that should work. Okay, okay.
Sorry, I'm just kind of breaking the noise function first in case we want to iterate in there. Ooh, interesting. What did you do? I like that. I don't know what you did.
I put test X and
Okay.
then test X, and here for
I
the
was
grid.
just organizing the code, but I like where you're going. I mean, even if we lost the rectangles, it's fine.
Or I guess no, it's just test. Test. And then what if I did test uv.x? I have no idea what I'm doing. I'm just plugging in and I don't think that this is what I had in mind, but oh, okay, so there's like a slight slant. That's not what I meant at all.
I like more the other thing that you had going on, kind of like an emblem. It looked.
I think that means just this.
Yeah, I somehow like that one. Though, I don't know, in the middle it looked pixelated to me. Does it look pixelated to you? Maybe it's just my screen.
It does not look pixelated to me.
Then it's just because I'm in a screen that is not retina in that monitor. Which, by the way, I'm just realizing that people cannot see the full picture. I'm gonna try to move this.
I don't know if I'm even seeing the full picture. I only see. Oh yeah, no, I do. Okay, so I curved the lines, and in doing so, got rid of the grid, which wasn't my intention. So let me undo that, because I'll keep the effect if we want to use it, but
I'm gonna put it full screen to show people, because I realize in the stream, since I always have to put us and the chat, then it covers, like they don't see the whole thing going on, so now they can see this like shape, abstract shape, which I like.
So I'll leave the shape for a second, but I wanted to make because this curves the line. I guess I need to multiply it by like time or something. Sine time. We've got like a little wave.
Cool.
Yeah. Feels kind of like I'm in a cavern.
I like it that it's a little bit abstract and it's not that symmetric at the same time that it is symmetric, but at the same time it does not look, because we only see like one part of the pattern in a close-up kind of way. And you increase the number now.
Yeah,
you?
just to see. I can put it back. Okay, and then what if I do test times n plus cos?
I'm gonna close this.
Not at all what I thought I was gonna do, but I don't mind it. It's very funny.
No, it's like a kind of slow motion effect,
Yeah.
I feel, no? Because you see
Yeah.
like the pattern moves and then this shadow moves kind of afterwards.
It's funny. It's like you have beer goggles on.
Yeah. This is the part that I guess as well Eliza and I enjoy doing a lot when we create stuff, just to sometimes randomly, like, you know, without really like planning or thinking like, oh, I want to achieve that, but just like trying things and see what happens. Kind of like learn by mistake, like you know. So I like the surprises, kind of.
Oh yeah.
Just like trying
Of being able
something
to
that
just, like-
I have no idea where it's gonna take me, but just to try.
I think that's one thing that's kind of a plus, I guess, about being like self-taught or whatever, because you have to kind of surrender to the fact that you can't necessarily implement a specific idea you have in your head every time. So there's more space to just like kind of play and see if I like, or you like the direction it's going, and follow that a little bit.
Looks like a candle casting shadow. Yeah,
Totally.
True. And hello, Agent Infinite, because I think I haven't seen this person either.
Yeah. I also don't recognize that name. Welcome, welcome.
Ooh, I really like it. I'm just watching our shader and I'm like, so
Let's
pretty.
make it really, really little. Like if I make it 50. Because then we'll see more of the pattern, right? Oh, that's not what I thought would happen. I thought that we'd get more of the top part would come down, but this is cool.
Do you want to push it? I can help you with that.
We could try and just see what it looks like.
I like
I
more.
like this though.
You like it more when it's smaller?
I mean, it just seems more like a wave. Like it looks almost like a leaf or something. But I don't mind. I have no.
I like more the
preference.
other one, because in here
the
I
other
don't
one?
see the
So
facing.
let's put back the.
Because I feel like this facing,
Oh yeah, you. prefer to see
it's
the-
hard to see when it's so small. But when it's bigger,
Yeah.
you see this facing down. Or maybe increase it, but not like so much. You could increase a little bit, but I wouldn't increase it as that it gets so tiny that you don't see this facing. Yeah, that's better.
But do you want to
So-
try and push it down?
Yeah, so
just to
you
see?
want to push the whole, yeah, okay. So that would be XY axis, yeah, and then, where is it? Here, grade I.
Oh, is it because of this guy in the modulo over here? The .5.
Okay, hold on. Are you doing that? Otherwise I was gonna do it. I don't think that's that, because that's...
No, go ahead. I was just clicking into it so you could see where I was.
Okay. But now it's black. No.
Is it? It's not black for me.
I think it's just for a second.
Oh, I
and then
see.
it's
Yeah,
gonna...
that makes sense. Ooh.
No, but
I meant to
that's
be
actually... that's
that's
different
not
than
usually
what
what
I
I like.
expect.
Ooh,
that's good.
pretty. I love sunset colors though. Ooh, cool.
Okay.
Oh, it's kind of
And then
fun
it's
with
gonna
the little
get
shadow.
darker, I guess, if I subtract it, but this is not what I was trying to do.
No, it is fun. It's like layer. I love layers though. All of the layering.
You like this one, I think. Didn't you?
Yeah. There's a certain quality about shaders that is really reminds me anyways of like playing with layers in Photoshop. And I don't actually love working in Photoshop in any particular capacity, but when I think of it like that, I'm always like, oh, cool. Oh, it's so fun. I love 2D that feels 3D. Love it, love it, love it. Do you like the colors, or you're not?
Oh, I love it. I love it, of course. Like,
Yay.
I don't know, this like Yeah, it reminds me either a sunrise or a sunset because of the purple and pink together, and then the yellow comes from the bottom.
What happens if you smooth the noise with smooth step? Ooh, I do love implementing smooth
Yeah,
step.
you can try that. Try that
Let's
meanwhile
see.
I'm trying to test if I can push as you wanted to see how it
Smooth
looks.
step takes 3
What if I
variables though. How would I smooth the
no,
noise
that's only
with smooth
affecting
step?
the color. How can I
How would I smooth noise with smooth step? I'm not sure how I would do that. How would I smooth out the noise? Because you get a float. Is the noise the smooth step ratio? And then what am I smoothing?
Sorry, it's black because I'm trying something here.
Oh, I see. I could smooth step this.
You could smooth step the noise simply like here. I would do it like noise equal smooth step,
Mm-hmm.
and then your floating number, and then noise. I would do it like that.
Yeah.
You need 2 numbers, right?
I'd have to, but smooth step takes 3 variables. That's where I'm confused. Yeah, exactly.
I would do it that way.
Okay, so if I do 0.5.
Try that way.
And then I'm just gonna put in a variable, and then I'm gonna put noise. That's not what I thought at all. Okay.
Maybe a floating number is better. I think because
noise
maybe
as the step.
I think it's gonna kind of like disappear. It's
not
very
what I thought, and I don't particularly. I like the like wavy feelings though. Yeah, I don't know. I'm not really sure how to do that. I'm just gonna remove it because it's gonna break, and I think you're trying to do something.
Yeah, I was
put
trying
it
to
in place
push.
of noise inside color. Put it in place of noise inside color. Put it in place of inside color here.
Oh wait, you're doing something? I'm gonna stop because then I cannot see what you're doing. Are you doing something?
Oh, I see. Okay, I'm gonna try something.
Okay.
I'm gonna try something. Okay, so I'm just gonna comment this out for a second, and then I'm gonna try in color smooth. I guess I would have to put it in here. Smooth step. If it doesn't work, I'll just delete it and go back. But I do want to.
Yeah, I'm glad that you commented because sometimes we kind of forget.
Not. Makes sense. That doesn't make sense. Put it in place of the noise. That's what you did already. I'm not sure then.
Just go back and I can try something else and then we can try again. Because I think I figured out how to push this thing anyway.
Oh yeah, do the push.
To see. Yeah, okay, I figured it out. So basically the way I figured it out is that I was thinking, okay, we want to push this oh, hold on, that kind of like move it too much. I think that was kind of, hold on, the yellow starts in the, okay, yeah, so it goes. So I figured that we have to move the y-axis a bit. But then I have the feeling that it's moving the y-axis, but at the same time it's pushing like everything else.
Noise vector.
Because if I do it in the x-axis, interesting.
Very lava-lampy.
Yeah.
Oh yeah, that makes more sense to me, Mitik. I should have caught that too. I'll try that in a sec.
Okay, now it's more.
Cool.
Let me see. Am I pushing it? Yeah, I guess I'm pushing
yeah,
it.
I think you're smooshing it.
But then yeah, so then I have to push both by 1.5.
Ooh. Okay.
And then
Got a little hole in the middle there.
yeah, I think now I'm
Then
finally pushing it. Okay, so basically I'm gonna really, so it was basically the UV, because how much do we want to push it? Maybe that looks interesting.
Yeah, it's funny. I like the little bubble on the top left right hand side.
A little bit less,
Okay,
like
wait.
this. Okay, I'm gonna stop now. I will leave this weird shape
Let me
on screen.
try something. Let me try flow test equals smooth.
I think you could
Guess I'll
do
call it
noise, so you don't have to, you know, as I was. Okay. Now keep on. I was gonna tell you that you didn't need a variable, but I'm gonna let you finish your idea and then.
All right. You're gonna tell me to just put it in there. No.
But you have a typo.
Oh, I always forget something or there's a typo. Did I get that right? Yeah, that's right.
Mm-hmm.
2 floats in a vec2. Still, I get nothing though. Why? Smooth, float, smooth. If I put 2 floats in a vec2, that should give me something. Why? Wait, but that doesn't make. I think that the noise has to be at the front.
No.
Because if there's nothing, yeah. I think that makes more sense.
I think the noise
But
has to be the last input. In smooth stuff, usually you have to fill.
But the ratio that you're changing, the ratio between the first, the second, and third is what's in the first position.
Hold on, I'm gonna try something. I'm putting back the noise.
Like, it doesn't work in the same way that mix works, for example.
Wait, now I don't see the noise at all. Hold on.
Smooth step doesn't work in the same way that mix works. Like mix, you put in the 2 things and then you put in the ratio after, but smooth step is the opposite. Smooth step is ratio first and then the 2 things.
Okay. I'm trying yours again.
Yeah, it doesn't work. maybe.x, maybe.y. I've never used smooth step this way though. I use it for like color cascades, but sorry if you can hear honking. Yeah, I don't know.
I will try something else.
Go for it.
Wait, I think you're doing something.
No, I was doing nothing. I just highlighted it. That's frustrating when that doesn't work though, because I understand how smooth step works. I just don't understand how it works with the noise function, because the noise function is a floating point number.
I'm gonna first try step.
Yeah.
For me, it's easier to start from there.
Totally. Why didn't we do that to begin with?
And this is what happens. We miss our gradient.
Okay.
So the noise is kind of okay. Cool. There it is. The noise is there, but it's more like.
But wait, so if I do smooth here and I add 0.3 here, then you're moving between 0.25 and noise with a ratio of 3.
But maybe 0 is better, I think.
What do you mean?
Instead of 3, because now we see only blue. And then in here, maybe even smaller, like he suggested. Or they, but then we don't see we lose.
This here is the number that you're using to divide between 1 and noise. So like in step function, you have a very specific line between 0.1 and noise. Or what did you have before?
I had 20. What was it? 35. And then we actually see the. Wait, I don't see it anymore. Why? Oh, maybe I had 0.5. Do you see it?
Yeah.
Okay,
So
no.
so
Okay,
you
with
see how there's
0.5.
like a very
Yeah.
distinct cut between the blue
Yeah.
and the yellow. So the number that you put in front of these two numbers
Mm-hmm.
is gonna make that blurry.
Mm.
So if you put 0, you're not gonna see anything. You should put
Ah,
something.
okay. So then
So if I
try.
do point,
Oh.
yeah, exactly. You
Ooh.
give me the H. Yeah. Right. Too many people.
I left. So
Okay,
okay,
so now
there.
it's blurry, but we don't see the
Okay.
blue, so we need less.
Oh,
Let's like do.
this is kind of looking like what is it called? Neomorphism. Neomorphism. I cannot say this. Do you know?
Neomorphism. What is this?
This is a design trend that came.
I don't know that term.
You don't know it? Ah, yeah, I can show you.
No.
Neomorphism. Oh God, this is a hard
I'm gonna
word.
Google that.
Is this design trend that came
We
into?
got it working though. I'm glad we got the. I'm gonna Google that. Neomorphism.
It's a
I'm
design
glad
trend
we got the
that
smoothing.
came 2 years ago in 2018. And it's when you have something that it's kind of transparent, so it's there but it's not really there. And it was really like in 2018 it was crazy, like even last year a bit, but more in 2018 I would say, like in a lot of UIs on the web, you would see it like happening, all these designs that were this with this neomorphism. And I felt that it was a little bit like that when you had, what number did you had? You had a different number and it was more transparent.
I put like 2. I think
2. Okay. Let's put it back for a second so that. At 2, not a 0.2, but okay. Yeah, that it's totally neomorphism to me. Did you find it in Wikipedia, by the way? Oh wait, I don't listen to you anymore. What happened? Oh, 9, your mic. Okay. Yeah.
my audio will for the rest of this. I'm sorry. I'm gonna sound like I'm speaking out of a tin can. I didn't charge my thing enough. My bad. Can I charge it?
The lines that. Yeah, probably. By the way, mimetic. Yeah, maybe the lines that we see are those graphs, but somehow I guess we perceive it when we see it like in a pretty way instead of just like a line, I guess.
Yes. Neomorphism, not neo. I was googling the wrong thing. CSS tricks. Neomorphism, aka neomorphism, is a new design trend and a term that's gotten a good amount of buzz. Its aesthetic is marked by minimal and real-looking UIs that are sort of new. And skeuomorphism. So many names to describe the same thing. But cool. Okay, so a lot of.
Yeah, I really like it actually. It was a big topic, like I guess because I'm a designer too in design world in 2018. It was a big topic because either you liked it or you hated it, because since it's a little bit transparent, you perceive the thing but not really, like, and it was like a topic as well, for example, on accessibility when it comes to design, like, why are you designing this thing, like, but aesthetically, like artistically speaking, I like it. It's like it feels.
Makes me think of here on the CSS tricks page. Of course, they're framing it in the scope of like UI, but it reminds me a lot of like a very gentle embossing, because they're using it to buttons.
Could be.
I definitely like it more when it's coming out and not going in.
Yeah. Okay.
Cool.
Yeah. What I like about it, I guess, it's just the minimalism of this, like design terms, that it's a bit transparent.
Yeah. I just flipped it to see. Took away the minus
cool
1.
Too.
Oh, right. That just.
I mean, I like both.
Do we prefer?
You can try even 0.5 and see what happens with 0.5, which would be in between.
I think I'm changing a 0.5, not in where you think I'm changing it.
No, I see. I see where you had it.
This is like my favorite hue.
I like it.
I do this? You could change it back if you Yeah, then we don't see it anymore.
Let's
What
try.
1.5?
Maybe you had to what? Maybe, yeah, exactly. That's what I was gonna say. Just a little bit less. Yeah, cool. Or you can try 1
I mean,
and see if you want to see it more. Because
just one.
I think you want to see it more.
Ooh. I think it's really dark. I don't know if I like the dark.
I like the 1.5 more, honestly. So.
Let me put it back at 1. Oh, we still have a viewer. Thanks for sticking around. Yeah, the internet crapped out as we were. I didn't even realize it because I was still talking to you.
Exactly.
My internet was fine. I was just chatting away. Like, do you want to do anything? And then I realized that she couldn't hear me.
I was gone.
But I think, yeah. So we implemented. I'm not sure, Mimetic, based on what you were saying before. I did try your idea, UVX times UVX plus UVY times UVY. I can't see a specific difference, but that could also be because of the smooth step. But now at least I understand better how to use smooth step with noise. That cool. Let me put back at 2 because I liked it when it was like very gentle. But,
yeah, me too.
Yeah.
I really like this neomorphism look. I really love it. It's like I'm in love with our shader again every time.
0. Okay, I'm gonna try one more thing. And
okay.
Then we're gonna go just because I'm curious.
Yeah. Shoot.
0.01 divided by this. Are you timesing or are you plus? You're plus UV.y. Usually I space out my equations, but Eliza, you don't. I start doing your I think I broke it. How did I break it? Looks like I did break it.
What? You're missing a what is it called? The parenthesis?
Oui. Yeah.
Oui. Very French.
Cool. Okay, so that does change. I see it. So it changes around kind of like
more like fire. It changes the color basically. So.
If I do it like 2.
I guess you're basically just influencing the color by doing that.
I like that. We don't have to keep these colors, but I like this idea. It's fun. Cool. But yeah,
I wonder what happens if you multiply it. Is it make it darker instead of dividing, you know? So.
Oh yeah, I think it would make it darker.
So it would be the opposite?
A little bit darker.
It looks the same. Oh, crazy.
You find? I feel like it's but sometimes I think I see things and I don't.
Hold on.
No, I think you're right.
It's
it doesn't.
The same.
I've never seen not make a difference. That's wild.
I just like to try sometimes, you know, to see if it's actually different. If instead of dividing it, if you actually multiply it, but it's.
Oh no, it does. It does. It flips the yellow.
Okay.
But otherwise, the colors stay the same. But I kind of like this hue. Okay. It's like mixed hues. Oh my god, the sun is out. It's been raining all day. We need to get off the internet so I can go take a walk. But what I suggest, thank you by the way, for Mimetic. Yes, it is very subtle. I love subtle.
The difference.
I suggest that we continue to tinker with this.
I like it as well, like so far. Yeah, we could, but I like it actually how we came up to this. In the 2 hours that we were, or more, did we stream more? We stream a little bit more, no? So
2.5 hours.
Wow.
Yeah.
I didn't even feel it.
Neither.
Which I love.
But I feel like I understand noise a lot better, so thank you.
Yeah, cool.
Thank you everybody who hung out with us. I don't know if anyone's still in the chat other than Mimetic, but it was really fun today, as it was last.
I guess so for me too, because this type of noise, the way that we implement it, I was playing with this just last summer, so half a year ago. So then, as you saw, it took me a second as well to like come back to it when I don't practice. So because I was doing it like just in the summer. I've been playing with noise nowadays in my own shaders, but in a different way. So, and I use the force too. So, which is a difference because a lot of these functions that we brought in from the gist are there. So you just kind of type noise instead of like putting in it, so you lose less time. So. It's a shame that we cannot do this like to coding in the force. Otherwise, I would suggest to use it. So.
But then the force only has one type of noise, whereas this, once we get more comfortable, we can use other types.
Yeah, of course, yeah. And that's the part I guess I like about this exploration, for example, kind of raw without this GLSL editor that we're doing, because since we have to bring in the functions or things that we want to use without having the GLSL editor kind of have it ready for us, we get to digest better, okay, how this thing works, you know? Kind of if you would like, if you wanted to understand how a radio works, like you, what is it called in English now? That you put all the parts out and then try to like build it up again.
It apart, put it back together.
Yeah, that's the word. Yeah, that's exactly how I feel when we are doing it raw in here without the help of like a GLSL editor. So
yeah, me too. But I feel like it sinks in better this way. I think I like the force for playing around and just getting ideas on paper really fast. But then this way, I find you kind of internalize what you're doing.
I'm gonna put for a second the full screen mode of our little shader that we did, because that way they can see it. So
I'm trying to take a picture for Instagram.
Yeah. Okay. All right, so I guess we're gonna go, and I think most of the people left when we were offline, but so we can say goodbye and wish everybody a good day, happy weekend.
Happy Saturday.
Enjoy the outside.
Wait, I closed the app. Let me just make sure. 6 people still tuned. Cool. Yeah. Enjoy the rest of your Saturday and see you in probably 2 weeks.
Yeah. Thank you for being here, everybody.
Thanks for watching.
Oh, like human.
Lego.
Wow. I didn't even notice that this like human person was.
Yeah. Good January. Good January. Yes. I saw that. I need to look at what everyone's been making for January.
Yeah, I've been using this hashtag.
If you just tuned in, there will be a replay.
Yeah.
I don't know if you're here the whole time.
We recorded this time, so you should be able to find the replay already on Twitch the next days, and then we will put it everything together on YouTube.
Cool.
All right. Bye, everybody.
Bye.